Hi, in this tutorial we are going to solve a question about dipole moment. The question is from your textbook, chapter 2 and number 6. The question asks you, make three-dimensional drawings of the following molecules and predict whether each has a dipole moment, and if you expect a dipole moment, show its direction. Let's start from option A. In option A, we have a molecule having a double bond, and it is a known molecule basically to you. It is ethylene. We have carbon-carbon double bond, and we have two hydrogen on this side of the molecule, and we have another two hydrogens attached to other carbon. So basically this is the shape of molecule, and this carbon has sp2 hybridization, and this carbon has sp2 hybridization, and bond angles are 120, the expected bond angles. So basically the shape of molecule or molecular geometry, we can say it's planar. And the second question or second part of the question asks whether this molecule has a net dipole moment or not. We are going to say automatically that this molecule does not have a dipole moment, a net dipole moment. The reason, it doesn't have any polar bonds, because carbon-hydrogen bond is not a polar bond. The reason, if you go to tables of electronegativity or electronegativities table, carbon has 2.5 electronegativity value and hydrogen 2.1, and the difference is 0.4, and we know that as a rough guideline, if electronegativity difference is less than 0.5, we say that the bond is not polar. Since we don't have any polar bond, this molecule doesn't have any net dipole moment. Let's move to second option, B, CHCl3. Let's draw its 3D shape. You know, if you have an sp3 hybridized carbon, so it is supposed to make 4 bonds. And how do we draw carbon with 4 bonds with 3D? You have to draw 2 solid bonds and 1 dash and 1 wedge bond. Okay, so this is the 3D shape of this molecule. We have 1 hydrogen in the molecule, and we have 3 chlorine. Let's place them arbitrarily. So I will draw the first chlorine here, second chlorine here, third chlorine here, and we will place hydrogen here. And we have 1, 2, 3 polar bonds in this molecule. The reason, if you go to electronegativity table, carbon has 2.5 electronegativity value, and chlorine has 3, so the difference is 0.5. So we say that this is going to be a polar bond. Then let's draw bond polarity vectors. So which one is more electronegative? Of course, chlorine is more electronegative. So we are going to have here a dipole moment vector or bond polarity vector, and here another vector, and here another vector. If you add these 3 vectors in 3 dimension, we are going to have a net dipole moment for this molecule. Don't forget, if a molecule is symmetric or symmetrically arranged, dipole moment is going to be 0 for that molecule. If you have same bonds, since we don't have 4 same bonds, this molecule is expected to be to have a net dipole moment. Let's move option C. In option C, again, we can draw the same way. We have a carbon. We can draw 2 chlorine and 2 hydrogen. I'm going to draw chlorines as solid or straight bonds, and I'm going to draw hydrogen with dash, and the second hydrogen with wedge bond. You know, carbon-hydrogen bond is not polar. We know, we discussed from option A, and we know from option B carbon-chlorine bond is polar. So we have here a polar bond, and this is the bond polarity vectors. If you add two vectors pointing upward, pointing this way and that way, the net dipole moment will be in this direction. This is the net dipole moment, this one. Okay, so we can conclude that this molecule has a net dipole moment. Let's move to option D. I'm going to solve option D here. Again, we have carbon-carbon double bond, and this side of carbon has two hydrogen, and this side of carbon has two chlorines. And we know that carbon-hydrogen bonds are not polar. Carbon-chlorine bonds are polar, and this molecule is a planar molecule in 3D. So there is going to be a polarity here and a polar bond. These are the vectors, and the net dipole moment, let's show with the red marker, it's going to be in this direction. Okay, we solved four options, but let's solve one more option. Let's say that let's add one more option to this question. Let's say that what for water molecule, let's say E for water molecule. Let me write the molecular formula. And do we have a net dipole moment for water molecule? We need to draw its 3D drawing. We have oxygen, we have hydrogen, and we have two lone pairs. Don't forget, oxygen is tetrahedral, or it has sp3 hybridization. So these are straight bonds or solid bonds, oxygen hydrogen bonds. This lone pair is coming out of the paper plane, and you can assume that, or you can think that, or imagine that this lone pair is going inside the paper plane. So let's look at, do we have polar bonds? Yes, oxygen hydrogen bonds are polar. The reason, if you go to electronegativity table, oxygen has 3.5 and hydrogen 2.1 electronegativity values, and the difference is 1.4. For that reason, the bonds are polar. And let's draw bond polarity vectors. Which one is more electronegative? Oxygen is more electronegative. The vector will be towards oxygen. This is the starting point, this is the end point, and there is another vector. And think of that two lone pairs. One is oriented coming out of the paper plane, the other one is going inside the paper plane. They will have also polarities, and it is expected this way. And since these two vectors, if it is added again, they will orient this way, and the net dipole moment is going to be in the same direction as this. So the conclusion, water has a net dipole moment. Thank you.